Okay, good morning or good afternoon, whenever you're watching this. I have put together a bunch of thoughts on the lab. In particular, Lab 4. Let's just talk about Lab 4. I think everything else I will, at least for now, put in writing. But you need to complete Lab 4 right now. You have one more week to complete the write-up. To complete Lab 4 and the write-up, we had extended it by a week. So it was due a week after spring break, and spring break was extended by a week. So we've lost 2 weeks in this lab right now. That's okay. It'll impact the final project, and that's fine because the final project will be difficult to do remotely. So I'm going to try to put details of the class in writing, but I want to spend some time today going over the multisim version of this lab. So you've already had 2 weeks to work on this lab. We had 1 week. The first week was an optional day to be in lab, and the second week was a required day to be in lab. So you should have a significant portion of this lab done. You've already been working on it for 2 weeks prior to spring break. And if you don't, that's a problem, but you are going to complete whatever portion of the lab you haven't completed within multisim. And so I want to go over, just to make your life a little easier, some of multisim in order to show you how to complete this lab in multisim. It really is no different than completing the lab in person, except that it's harder to make errors. So the lab becomes a lot easier when you're doing it in multisim than when you're doing it live. And that's a shame because the troubleshooting of labs is a big part of this lab, but that's what we're going to be missing out on, and there's really nothing we can do about that. Of course, I could send you all lab kits, but I can't send you all oscilloscopes, etc. So we're just going to complete this lab in multisim. There are some issues with Lab 5. Right now we're completing Lab 4, and you've got one more week to complete it and do a write-up, a full write-up. It's a formal lab. Lab 5, we have some more advanced functions which require a paid version of multisim, and I will think about that a little more, or if we can just rewrite the lab. Lab 6 is Arduino programming, and I have some thoughts about that too, which I'll put in writing. But let me get to today's lab, Lab 4. You already have had a video lecture on this lab. You can go back to that video lecture and you can go through it if you don't remember what we're doing, if you haven't looked at this in 2 weeks. But let me go through some things in multisim that we've already gone through in the video lecture of the lab. So first of all, remember when you get into multisim, you can go ahead up here and create a circuit. Click on create a circuit. And let's say I want to just create a voltage divider. I'm going to choose a resistor, put down a resistor, choose another resistor, put down a resistor, choose a power supply, put down a power supply, rotate that power supply, and go ahead and attach all of these things with wires. Boom. I could pause the video while I'm doing this, but I'm not sure that that's necessary. You can just watch the video, or you can always fast forward through spots you don't want to watch anymore. So I've gone ahead and connected that, and of course we always want to make sure we know where our ground is, so we're going to ground the negative side of the battery. That's the default unless there's a reason to do otherwise. And so this is a voltage divider. If I want to run the voltage divider, I'm going to hit run, and oh boy, that's exciting. Nothing's going on. We can actually look at a graph, look at a graph. Oh, there's no probe because so we don't know, it doesn't know what we want to graph. Okay, stop. I'm going to put a voltage probe. I'm going to put it right here. What should that voltage probe read? Oh, well, there you go. It says it's reading 12 volts. It's reading 12 volts because it's reading the voltage between ground and where I put the voltage probe, which is across the battery. That's 12 volts. If I push go, it's just going to graph a constant 12 volt voltage over here. That's what an oscilloscope would show because this is a DC voltage. All right, let me go back to the schematic. Right now I have a split screen to see the oscilloscope. Go back to the schematic. Okay, stop. So with a voltage divider, I can put the probe up here, and you can tell me what voltage we should see when we start it. it should be split equally between the two resistors, and there we got 6 volts. Okay, so we already know how to do things like this. Well, one thing about a voltage divider, I'm just going to throw away my probe, is that you use a voltage. We're beyond voltage dividers, but I just want to show a function that I realized in multisim. One of the things we use a voltage divider for is to reduce a voltage. So we've got a 12 volts here and 6 volts across this resistor here and 6 volts across this resistor here. So if we want a 6 volt power supply, this is how we get a 6 volt power supply from a fixed 12 volt power supply. We would use one of these resistors as our power supply. So theoretically, or essentially, what we would do is we would take a wire and we go like that, boom, except for the fact that multisim won't let me just put a wire to nowhere. Right, whoops, it's not letting me do anything. I want to just put down a wire and show that I'm going to use 2 wires coming across from this resistor as my new power supply. So the function in multisim is actually a connector, and that makes a lot of sense because wires go to nowhere, but connectors, a connector implies that it's going to be connected to something. We just don't know what it's connected to. So a connector is essentially a wire to nowhere. So the connectors are with the schematic are with the grounds, right? And so I could put a connector here and a connector here. I'm just putting it down and then dragging it to make it longer. Okay, so now that shows that I've got 2 wires across the resistor R2, but I don't know where they go, and it doesn't matter where they go. And that's just for a schematic for my diagram, just to show I'm going to use those 2 wires as my power supply now. So that was a discovery I made in multisim, is how to make wires go to nowhere, essentially. Okay, what else? Okay, one other function I found that makes life easier in multisim is a junction in a wire. So I want right now all of your junctions are where the wires connect to the devices. So right here is a junction, and I can have a wire come from there and go somewhere, except it can't go to nowhere. And right here is a junction, and whoops, I'm hitting escape to get rid of that every time. Right here is a junction. Okay, if I don't like it, I can just hit escape. But I can't actually make a wire just come right out. Whoops, see, when I grab that wire, it just makes it longer or shorter, so I can grab it and I can change it. But what if I want a wire coming from there? What I need to do is use a junction. So again, that's over with the ground. You go to junction, and now I can go from anywhere there, and I can attach a resistor or something or whatever. Again, I can't have a wire going to nowhere, but the junction is a useful thing to be able to attach things to any arbitrary place on a wire. So, for example, if I didn't want to attach my wire right to the resistor here, but I wanted to, let's just say I wanted to put another resistor in parallel with this power supply. I could take a resistor and I could go put my resistor right here, and then I could take a junction and say I want a wire coming from right here to my resistor. That's the only way I can do it, is with a junction, right? Otherwise I can't take a wire from there. If I want, again, a junction, I can take a wire from right here and go to my resistor. So a useful function to know if you weren't already aware of the junction function. Okay, let's just look at because we're going to use this more extensively, let's go ahead and look at the things available to you. Multisim Live is a free version. There is a paid version of this program which has a lot more of things available to you. The student version costs $44, and if you want that student version and you want to be able to download it and install it on your computer, it will only install on Windows computers. That's a thing about National Instruments stuff. It'll only install on Windows computers or on a virtual machine on a Mac. But you will have a lot more functionality, and you don't have to be in the cloud. I know some people had complained that there were some issues with the server going down. I haven't seen that yet, but I believe you. If you want to pay $44 and get the student version, go right ahead, do that. You'll have a lot more functionality. It'll be quicker to react. You'll have it on your own computer. You don't need to be on the internet. The other thing is that I have not installed it yet, but what I read is I believe that the student version or any version, paid version, is free for 30 days. So to that extent, you can just install it, use it for 30 days and be done. I didn't actually count the number of days left in this lab, but I don't believe that you would need it for more than 30 days. So obviously, you can just do it for free if that 30-day trial, if I'm correct about the 30-day trial. So you can go ahead and download multisim as a desktop application. Use it free for its trial, pay $44 for the student version, and not deal with the cloud. And have more functionality. So let's look at what functionality we do have. We have voltage probes. I haven't used a current probe yet here. Actually, we rarely measure current, even though it's an important thing. The digital probe, that's an important one when we get to digital circuits. That just tells us whether it's high or low. You don't worry about the value of the voltage. So the digital probe is right here. Okay. Then we went through these. The ground, we always have to have ground. The connectors, a wire to nowhere, a junction. We just went through that. Power supplies, we are going to use either AC voltage or DC voltage. So there's the AC voltage and the DC voltage for a function generator or a battery. Resistors, capacitors, we're not actually going to use probably any of the rest of these things, but resistors and capacitors. Op amps, here are the op amps. Diodes, we're definitely going to use diodes and LEDs. Transistors, we're definitely going to use an NPN transistor. Light bulbs, oh, and LED again. Oh, I didn't actually look at these. Interesting. 8 LED bar and buzzer. Okay, anyway, we're going to use the LED. The switches, we're going to use a switch. Now that we're in lab, I had often said, don't bother with a switch, just attach or detach a wire. Well, we'll use switches for real since we're using multisim. And let me go ahead and put down a switch and attach a wire. I'm just going to attach a wire from here to here and a wire from here to here. Okay. Now, when I run this circuit, I can just click on the switch to close it, click on the switch to open it, click on the switch to close it, click on the switch to open it. And so you will see, I'll use that for good in a second. Okay. And then going down to the bottom, we're going to skip these weird things. And here's the digital stuff. The digital stuff is what we're getting into with this lab. This is our first digital lab. We've got the AND gates, the OR gates, the NAND gates, the NOR gates, etc. There's different kinds of gates, 2 inputs, 3 inputs, 4 inputs. The typical 2-input AND gate right there. And okay, so again, I'm just showing you what's available. Here's the AND gate. And remember what an AND gate is. We can have an input A and an input B, and then it does the logical AND function, and the output is either high or low depending on whether the 2 inputs are high or one of the inputs is low. So how do we do that? How do we actually do that in operation? And we'll get there in a second, but I'm just showing what functions we have on the left-hand side. You could attach a power supply, a DC power supply to A, and we could attach a DC power supply to B. We could attach an LED to the output to see whether it's high or low. And we could attach a switch with the DC power supply and turn it on and off. And so that would be sort of analog inputs and analog outputs. But there's also digital inputs and digital outputs. The digital constant is your digital input. So here's a digital constant. That's just a 1 or a 0, right? It's like 5 volts or 0 volts. We can, when we run it, we can turn it on and off. I'm going to attach a digital constant here. Now, this is important because in the lab, I had said the one thing that I didn't talk about in the video last week, or in the video for this lab, was the pulsar and the probes. These are the identical thing to a digital pulsar and a digital probe. A digital pulsar is something that puts in a 1 or a 0. It puts in whatever for that chip is equivalent of a 1 or a 0. It might be a 5 volt or a 0 volt signal. And a probe is something that just detects if there is an output. So the probe is this digital output, right? So I'm going to put this digital output right there. Now this currently is going to nowhere. So I either need to make it go to an LED, or I can make it go to a connector, right? A connector to nowhere. Put down my connector, turn it so that I can attach it. And so there's my connector. I'm going to drag it just so it's farther away. So now I've got what I had talked about that I needed to show in lab is a pulsar and a probe. These are the pulsars. They'll put in a 1 or a 0, and the probe here is just going to detect what the output is. So I'm going to go ahead and play. Okay, so when I play, wait a second. Why isn't it telling me? Let me turn this off, Oh, it's because my probe is not actually attached. Hold on. Somehow I didn't get that probe attached. Digital. Okay, there we go. All right, so now let's play. Turn on, put a pulse in here and a pulse in here. And notice when this is an AND gate, so 2 high values gives me a high output. D is high. The digital probe is high. So there's my pulsar and my probe. Okay. Whoops, I'm going to go ahead and play again. Turn this one off, right? And then it goes low. Turn this one off, it stays low. Turn this one on, it's low. This is an AND gate, so it's only going to be output high when the 2 inputs are high. Okay. So that those come from these digital. These are the only digital things that we have. Here's the digital constant is what's the pulsar, is what gives us the digital input. And then the digital probe comes from the probes up here, the digital probe. Okay. So those are all the functions on the left-hand side that you need. So now let me go to the lab in particular. Okay, let me just show you another circuit which I created. My circuits, whoops, I should probably save this just in case. File, save. Oh, make sure you know these functions, right? You want to save your circuits. You can export to your circuit as a picture. If you have run the circuit, you can export the oscilloscope, but with the grapher image, you can export the schematic image. You're going to want to be regularly exporting schematic images of things going on. Let me show you that next. So I'm going to go to my circuits that I've created. I need to save this. Save as, I'm just going to say lecture example. Okay, let me go to my circuits, and I had created a circuit with an LED. Oh, here it is. Nope. Where is it? Pausing. Okay, I missed it. LED on and off. Okay. So I've created all these circuits. There we go. Open circuit. For this lab to just show you some examples of things. Okay. Another function that you may not be aware of is if you currently put your hand, right, the hand that is your cursor, you can grab individual items by clicking on them. You can grab individual items by clicking on them. If you want to grab a whole bunch of items and delete everything at once or move everything at once, you use the control key. So I'm going to take my hand away from the circuit, hold down the control key, and then left click my mouse so that I can drag a box around the whole thing. That way you can move the whole circuit or you can delete the whole circuit. Okay, so that's just using the control key, control and then left click drag. Okay, so here what I've done is I put an LED in a circuit. I put a resistor because that's a good practice to not burn out your LED, to not blow up your LED. I put a ground in here because you always have to do that. And I just have showing here 2 power supplies, right? One which will forward bias the LED and the other which will reverse bias the LED. Okay? So what I want you to notice is that, okay, and I have 2 switches, so currently neither power supply is on. So I put this circuit together. I'm going to go ahead and run it. First, I'm going to reverse bias the LED. I'm going to go ahead and just close this switch, reverse bias the LED, nothing happens, right? So if you were going to try to show me, if you're doing this lab and you want to show me what you're doing, you could go ahead and stop this, oops, click away, okay, stop that, and you can go ahead and export the schematic image just to show me what you're doing. Okay, then I'm going to go ahead and keep playing. I'm going to open this, and I'm going to close this. What's going to happen when I close this switch? I'm forward biasing the LED, and the LED should light. And look, what happens? The LED actually lights. That's the beauty of the simulation. It actually works. The LED actually lights, and so I'm going to go ahead and, I wonder if I can export midstream. I guess I can, but I'm going to go ahead and stop. But if I stop it, it's just going to leave it in the state that I had it in, and I can export that. And then you can, right, export it as an image, save that image, and so now that's showing me the LED lit. So this is the kind of thing you're going to need to do in order to write up this lab. You're going to need to run something and show me what you're doing, and show me how the circuit reacts. I'm going to go ahead and keep running this. I'm going to open this switch and notice the LED goes off. Close this switch, LED stays off. Close this switch, LED goes on, off, on, off, on. What happens if I do both? Yeah, the two power supplies balance each other out so that there's no power. But anyway, so there you go, on, off, and you can export the image with it on, export the image with it off. You're going to need to do that in order to show me your write-ups. I mean, you know, in order to write it up and show me what you're doing is what I mean. Oh, sorry. Okay, I'm going to actually stop this video here because what I've just done is done a quick overview of the basics. Let me look at a couple more basics, and then I'm going to get to the specifics of Lab 4. Again, the grapher is the oscilloscope. There's various things that you can set over here, right? Clicking on this, things for the circuit that you can set. You can click on an element and set the various things about the element. You can always click directly on the element to change it, but you can also use the settings over here in order to set various things for, you can see all the settings for each thing, right? This is a DC power supply, 5 volts. Anyway, so there's that. Let's see what else you need to know. These buttons up here are the same as these buttons here, file navigation menu. This is the export button. This is the full screen view. Over here you've got the export. I'm not worried about stream to, saving files. And I think that covers all the functions on the screen. Of course, this is just zooming in and zooming out to show more or less, depending on what you're trying to show me. Okay, so I'm going to stop here and then start a new video which specifically addresses the lab 4.